Hello everyone and welcome to another problem solving video here on Code. Before we begin, I just want to issue something of an apology to you guys because I know it's been a while since I posted another video, but I had been quite busy studying for a professional certification and I wanted to be completely focused on my studies. And now that that's over with and out of the way, let's get on to the problem that we have here. It's a very easy problem off of Leetcode. It's problem number 27, which is remove element. What you have in this situation is an array of numbers and a value from the array that you want to remove. So as you can see here in the array, we have 3, 2, 2, and 3. And the value that we wish to remove is 2. After we find 2 and replace it with an underscore, or any character for that matter, we see that the result is 3, 3, and 2 blank spaces. Now k in this situation represents the number of elements in the array that do not match our value that we've removed. So the number of elements in our array that we've modified after removing 2, we see 3 and 3 twice, k is now equal to 2. And this somewhat represents the actual size of the array. Now, some languages do not support, or they only support fixed size arrays. So languages like Java, only support fixed size arrays, but in fairness to Java, there are dynamic data structures such as linked lists, array lists, so on and so forth, where you don't have to deal with fixed size arrays. However, for this particular problem, we have to deal with fixed size arrays. So that's a bit of a problem that we're trying to resolve. So we have another example here where we have 8 numbers. And we want to remove 2 yet again. We see in the array that 2 appears 3 times. So as a result, we're going to end up with an array of where k is equal to 5 because we've removed 2 3 times from an array that contains 8 numbers. So remember, the challenge is what do we do when we have fixed size arrays? So as we'll see in our algorithm, what we're going to do is we're going to, when we replace those numbers that we find, we're going to place them at the back of the array, and we're going to keep the values that do not match the value that we're looking for towards the front of the array. So let's go ahead and take a look at our algorithm. So as you can see, we have an array of 4 elements, 3, 2, 2, and 3. Our value, or the number that we're going to remove from the array, all instances of it, is equal to 2. K is equal to 4, which is the length of the array. Now we're actually going to work backwards and decrement values from k as we find elements that do not match the value we're trying to remove. And I is just going to be the variable that we're going to use to keep track of the index as we traverse through the array. So let's go ahead and get started. The very first element at index 0 is 3. Is 3 equal to 2? Obviously not. So let's go ahead and decrement k by one value, 3. And let's go ahead and move on to the next number. So we increment I by 1. So let's go ahead and draw a new array. And this time the index is 1. So is 2, which is the number at index 1, is that equal to 2? Yes. So let's go ahead and substitute that 2 with a negative 1. Now we still have some work to do here. We want to get this negative 1 at the back of the array. Now one way that we can do that is we can have successive swaps where we swap the current number, which is negative 1, with the next number, which in this case is 2, and then swap it again with 3, which is the very last number. But there's also a trick to this. If the number is equal to the value we're trying to remove, we don't want to swap that number because we have to go ahead and process that number at some point. Also, if the number is also negative 1, then it's not a number we want to swap because we'll just be swapping the same values. So let's go ahead and swap our numbers here, and what we end up with is 3, 3, 2, and negative 1. As you can see, we skipped 2 and then we swapped -1 with -3, and that's our new array. All in place. We're not modifying the actual array sizes or copying anything over. So let's go ahead and process our next number. I will then go to 2. At index 2, we have the number 2. 2 again is equal to 2. So we'll do what we did in the last step, which is go ahead and substitute -1 with it. And then we perform our swaps. But as you can see, the very next number, which is also the last number in the array, is -1. And under those conditions, we don't do any swapping. So let's go ahead and let's decrement k by another number, which is, leave it at 2. And then let's increment I to 3. Let's go ahead and draw our array again, just for clarity here. And then index 3 is here. And that's a -1. And we're not going to process the -1 because the -1 indicates a value that was removed. So let's skip that number and go to the next one. We increment I to 4. But 4 is the actual length of the array, so we're done here. And then k is equal to 2, which is correct because we have two numbers that did not match the value of 2. That's 3 and 3 again. So let's go ahead and run some more test cases and see how everything looks when we run it in our code. Okay, so here we are with our JavaScript code solution here. Before we begin, let's take a look at all of the different functions that we've implemented here and give a brief explanation on how the functions work and their purpose in our code here. So there's remove element, and then there's a remove element in place. So why do we have two functions similarly named that appear to do the same thing? The very first function, remove element, uses the splice function, and that function will remove an element at a certain index in the array. It's very convenient compared to our in place solution. And according to the JavaScript documentation on Mozilla, using the splice function won't necessarily change the array. It won't change the dimensions of the array or the length. So according to the question on Leetcode.com, the removal of the elements had to be done in place. So you could argue that we're still doing the same thing with remove element. But I went ahead and created this remove element in place function because I wanted to make sure that we would be covered for our requirement. Feel free to go and get a copy of the source code. Our GitLab is posted in the description, and feel free to run the remove element yourself and see how it works. But our element in place, this is the function that we're going to be testing throughout the rest of our code view description here. As you can see, we are not using -1 here. We're just going to go ahead and use the underscore character. We don't necessarily have to use -1. We could use any value that we kind of see fit, so long as it isn't a value that is equal to 0 and less than 100, because that's the constraint that the description gave us from Leetcode.com. So as you can see here, we're going through all of the elements in the array. When the number is equal to the value we're trying to remove, we go ahead and sort of delete the character, delete the number by substituting it or assigning it the delete character, which again is just an underscore. We create a copy of m, a copy of I, by assigning it to this variable m. And you can see here, as we saw in our algorithm view, we go ahead and decrement k. Now, for this for loop here, this is performing all of our swaps. So the starting position, which is going to be j, is going to be m, which is a copy of I, or the current position, with 1 added to it. So it's always going to be the next index over. And then we traverse the entire array starting from position j all the way up to the end. And what we're doing here is, just as we mentioned in our algorithm, making sure that we're not hitting a -1 or a value of 2. this n value here is a little bit redundant, so I'm just going to go ahead and remove that. And let's take a look at the next function, which is a judge function. This was straight off of Leetcode.com. It's just code that they have included there to give you an idea of how your program is going to be judged or determined if it works correctly. So as we can see, we run our we execute our function remove element in place. We store its value into k. K is the number of values that did not match what we were trying to delete. Of course, we run an assertion. If anything's wrong, we'll know about it when we run it. And interestingly enough, we sort our numbers because in the very next few lines that you see here, lines 54 and 55, we're going to be comparing all of the numbers in our array to the expected result. So we sort the numbers because our expected result is going to be pre-sorted, or already the numbers are already going to be in order. Looking at our test function here, we see a bunch of test values. All of them are objects that contain the input that we're going to be testing against. The value, of course, we've said that many times, just the value we're going to remove from the input, and the expected result, which is what we're going to compare after we run our remove element in place function. And of course, just a for loop to make sure that we run our judge program for each value. And then we just make a call to the test, which is just a global function. So let's go ahead. I think we're ready to go ahead and run this right from IntelliJ and see our results. Remember, if we have a failed assertion, we will know about it. And we do not. So I think we're ready to go. We're ready to go ahead and test this on Leetcode.com. Okay, so here we are on Leetcode.com. I think we're ready to go. The remove element, as you can see, that function contains all of the code that we had in our remove element in place function, but everything should still work. So let's go ahead and let's run it and see what happens. Okay, Leetcode's doing its thing. Okay, looks like case 1 and case 2 pass, so I think we're ready to go. Let's go ahead and fire it off and see what happens. Leetcode's doing its thing. Okay, and we have an accepted solution. As you can see, we can look at some of our performance metrics here. CPU wise, we didn't do that well against all the other solutions. We only beat about 28.5%. But what we really did good on was the memory consumption, where we beat almost 98, just a little over 98%. So again, you can take some of these results with a grain of salt. There's always room for improvement. So as always, if you guys have any suggestions or you feel like you can improve on this design, always feel free to leave a comment in the comment section. I truly hope that you guys enjoyed this video. Thanks for watching. And if you have a moment, please like and subscribe this video. It'll help the channel grow. And I will see you guys in the next video.